Confidence interval for population proportion. Forget those symbols. I'm using words. There's the formula. Write down the slide number 26. So let's see, the first week was slide 10 was the formula, the second week was slide something else, and the third week of slide 26 is the formula. There's the three main formulas until we get to Thursday, because we got another formula coming up Thursday that's really important to find the optimal number of your sample size, the optimal number, which is Thursday's lecture. But today, I always put the formula in words, so that I want to put it in words. The proportion, matter of fact, we can call that the given proportion, the proportion plus and minus the z, which we got to get this, the Excel equation to find our z, times, here's the tough part, that square root is over this whole thing. I want everybody to hear that again. I can't tell you no matter how much I say this right now, and we're recording this, and someone's going to watch it. Someone's going to put that square root over the numerator only or the denominator only. That square root is over the whole thing for a proportion. I know the first 2 weeks the square root was just over the sample size, but not for proportions. It's over the whole thing. Proportion times 1 minus the proportion divided by the sample size, then square root. Matter of fact, I put the order of operations here. This is how badly I want you to have success on this part of the quiz. The order of operations is, number 1, subtract in the parentheses 1 minus the proportion. Number 2, multiply whatever you just got, 1 minus the proportion times the other proportion. Number 3, divide. Now divide that by the sample size. Number 4, now use square root. Number 5, multiply times z. Number 6, add and subtract. There's the order of operations. You are going to be successful with these proportions if you follow that. This is the one that has the most math errors, and it's that whole darn part in the parentheses here is where it happens. Right? You cannot do this division before, you cannot do this multiplication before you do that subtraction. You can't do that division for that subtraction. You can't do that square root before that first subtraction. You got to do the parentheses first. All right, let's do an example. We're literally plugging it in. We're going to take it all, get the whole setup. We're not going to take it all the way solving it, but we're going to get the whole setup. Here it is. Random sample of 100 people shows that 25 are left-handed. Form a 95% confidence interval for the true proportion of left-handers. What's the successes we measure? What are the successes we measure? In words, not how many. In words, what did we measure and we're calling it a success?
25?
No, not how many. 25 is correct. On how many, I'm asking you what is the success we're measuring in words?
How many were left-handed?
Left-handed. We're measuring left-handed people. That's the success. That's what the word means, success, is whatever's being measured. And don't let the word success mean something positive, like in real life. Not at all. It's just whatever's being measured. In this case, it's left-handed people. So the success is left-handed people. How many? 25. What's our proportion? How do I find my initial proportion to get this problem started? There it is. 25 over 100 is going to equal my proportion, which happens to be 0.25. Everybody with me? There's 3 of the numbers. 3 of the numbers. There it is. And now all I need to know is my sample size, which is how many? There it is, 100. And my z. Now, which formula should I use? Now, this is our time to learn the new formula. Let me bring this up. Here we go. Is it time to go to the free food? Oh no, we only got 16 minutes. Oh, man, how are we passing out free food? I would have skipped class if I were you. There's free food in the courtyard. If they were giving out t-shirts, I would have never been.
No, they're just giving out.
Yeah.
If you get them, yeah, yes.
You just spend something and possibly get a t-shirt?
No.
Oh.
Or cash.
Where am I at? Okay, here we go. NINV means you would put in the confidence plus half the significance, and then you'd put a 0 and a 1 for the other 2 numbers. This is what we used in week 1. But I want to show you, here is norm SINV, which we didn't learn in week 1, we learn it now. And this one, you only got to put the confidence, where is it at? Right here. Plus half the significance. You don't have to, you're just dropping off the 0 and 1. There's the difference. The bad news is you still gotta use the confidence plus half the significance, which is the tough part for a lot of people. But there's the formula, so I wanna use the new one. So here we go, I'm solving this problem. Whoop, let me get the problem back here. I'm solving this problem just like it's a quiz problem here. Find the confidence. Here we go. I know it's 0.25. I'm gonna do my formula here. Someone get their calculator out, or not calculator, Excel out, and enter this in. Norm dot S dot INV, parentheses. Help me out here, look at this problem. What should be the number right here? 0.975, very good. All right, because 95% confidence means 5% significance, half of 5% is 2.5%. Added to the 95 makes 97.5% confident, or what we're putting in for the first number, excuse me.
Oh, we could use either or?
Yeah, either one of those two, either one, but they both gotta have confidence plus half significance for the first number. So you're not really, it's gonna be hard either way, because you gotta remember to do this for Z, but not for T. That's what's weird. So now we have our number. Somebody entered that in and got what?
1.96.
1 point, come on, what's
Zero.
it, 9?
60.
60? 60?
If you
Is it right? Is that true? 60? They never turn out like that. Seriously? 1.96. Now we got this. Here we go. I'm ready to do the setup. Are we ready? This is manual, so I don't have to put the equal sign in front, but I'm used to it, so I'm going to do it. 0.25 plus and minus 1.96, big parenthesis. Watch what I'm doing so I don't forget. Giant square root symbol right away, so I want to make sure I remember it's over both of them. Now here's the top, 0.25. I'm putting the asterisk times 1 minus 0.25. For manual, you don't have to have asterisk. You have to have that asterisk for Excel though. Over the sample size, which is 50 or 100? 100. Parentheses. There's the setup right there. 0.25 plus and minus 1.96. Parentheses. Square root this whole thing. 0.25 times 1 minus 0.25 in parentheses. Over 100. Square rooted the whole thing. Now, if I were solving this, gotta give me two calculations. I would subtract parentheses. 1 minus 0.25 is 0.75. Multiply that 0.75 times 0.25, you get whatever you would get. Whatever that is. 0.18, I don't know. Then divided by 100, whatever that is. Now we're at 0.0018 or whatever it is. Then square root it. Now we just made some big number, bigger number, 0.16, who knows. Now multiply it times 1.96. Now take that result, add and subtract it to 0.25. And we found our upper and lower limits, which happen to be 0.25 plus or minus 1.96 times that whole thing in the parentheses is 0.0433 after we square rooted. So our upper limit is 0.3349 above 25%, 33.5%. And our lower limit, 16.51. I'm going to answer your question in just a second. Hang on, here we go. Well, here's our proportion, 25%. Our upper limit is up here at, what was the confidence, 95%? 95%, so we're way out here, 1.96. So I'm going to make this 33.49%. And down here's the lower one, 16.51%. What did we just find? What did we just find right here between these two numbers? Here's what we found. We can say with how much confidence? 95% confidence, based on the sample we did from that proportion of how many were left-handed out of the 100 people, that if we had the time to ask everybody in the world, well, I don't know, whatever the population is, but that sample, maybe that sample is just U.S. citizens. If we could ask every U.S. citizen if they're left-handed or right-handed, the proportion that are left-handed with 95% confidence is somewhere between 16.5% and 33.5%. We can say that with that much confidence and know it's true. That's what statistics does for us. It allows us to make that kind of an estimate. Now, don't get me wrong, 33.5% to 16.5% is a pretty wide gap. How, if you're a researcher and this were true research and you wanted to lower that gap, the easiest way to do it, increase your sample size. And that's what's going to lead us into Thursday's lecture. And Thursday is how we determine what sample size
we need to get the kind of confidence we want. If this were really important, we wanted 99% confidence, our sample size has gotta go from 100 to a whole bunch more than 100 to get to that 99% confidence. So that's what this is all about, using samples to learn about a population that we can never ask everybody in the population, are you left or right-handed? Well, we would never be able to do that, it would take forever and tons of money.